Alright, so yeah, good afternoon again. My name is David Power, and this afternoon I was going to speak to you about the Boston Igloo storage range. And since my background is in HPC, I'd like to spend a few minutes as well just discussing some of our ScaleOut storage solutions as well. The Igloo product line is, again, it's a series of servers that are tightly integrated with storage platforms to provide enterprise-grade solutions for any storage requirements and budget. We have a range of offerings right through from, we heard from the guys earlier on from OpenE, Windows, Nexenta, and DataCore as well. Essentially, it's a range of software-defined storage appliances that are sort of tightly packaged and developed and integrated with our partners for a fully supported platform. They're built using, of course, the low, cost-effective commodity parts from Supermicro, and we kind of build value up on top of that and engineer to support it ourselves. We've won a number of awards over the past while from IT Pro and from PC Pro as well for our Igloo server range. All of the products that I'll be speaking about today are fully certified by the guys in Boston Labs. So we'll take the products in, we'll spend weeks and months testing them, evaluating them, ensuring that everything works correctly together. I'm getting a slight bit of feedback, I'm not sure where that's coming from. We'll carry on. I presume it's the bad weather outside. But anyway, each product will undergo extensive stability testing and benchmarking to ensure that the right standards are met. And again, our team are fully certified to install, support and maintain all of these storage technologies, giving you peace of mind that we're not just delivering you a piece of kit and running away. We're there to help integrate, get it up and working, and get it functioning to your requirements. Again, Boston Labs is a facility that we open up to all of our partners and customers as well, so if anyone is interested in evaluating or testing any of these products, feel free to get in touch and we can enable remote access or invite you in to play with the hardware and get hands-on with them as well. We have a very, very wide range of chassis options, which gives us a huge amount of flexibility. And I mean, you can see there from in front of me, we can really sort of optimize the cost per terabyte or the amount of storage that we're looking to put in with storage solutions, be it right up from a 12 bay, 3.5 inch, all the way up to 72 drives with a small form factor in a 4U bay. So again, depending on what the requirement is, we can optimize the solution around your requirement, and again, also allow you to kind of grow that in future as well. Two of the solutions there are double-sided, allowing us to put drives in the front and back, and those who are familiar with the Supermicro range will be very aware of those products. As well as the chassis, there's a full range of JBOD expansion options as well, and all of these come with the usual redundant PSU, single or dual expanders, depending on if you want to use SAS and have high availability, and of course all the rest of the features that you'd expect from JBOD. So there's not only a solution when you put it in, but you've got this expansion option as well further down the line when your users come roaring at you for more space. To start off with, and I'll just touch on this briefly, as I know the OpenE's guys did a great job of explaining their product earlier on. The slides I have here are actually based on the DSS V7, which is one of our sort of main sellers at Boston. I mean, it provides a kind of a unified NAS and SAN solution inside the box with a nice user interface to allow people easily administer their storage and get on with their daily task instead of having to spend ages actually configuring storage and deploying it and so on. It's a rich feature set. We can do it in single mode or in high availability mode. And again, it's very, very cost effective as well. So it provides a huge range of features at a very, very compelling price. Again, these are many of the features that they've already provided. I'll let you kind of read through those, but essentially if you're doing anything with iSCSI, CIFS or NFS, it'll do all of these guys straight out of the box. Plenty more features as well, and this is their older product as well, so this feature list is even more enhanced with the Juniper product that they launched today. And again, depending on what your requirement is, this can be a very cost-effective standalone unified NAS or SAN, or if you wanted to implement high availability, we can put in a second system and allow you to do iSCSI replication across 2 nodes and provide them then as a highly available solution for your environment, which is very, very appropriate for cloud storage or even virtualization. This is just a sample configuration of one of the typical configurations that we put together for a solution like this. On to the next one, which is Windows Storage Server. So again, this provides us with a unified NAS and SAN solution, but it allows enterprises to leverage a lot of their existing in-house skills. So any of your administrators that are used to using Windows and administrating Windows systems, you can leverage those existing in-house skills and extend it through using Windows Storage Server 2012. It's also incredibly cost effective because you're just paying for a license for the node rather than paying on a license per amount of storage used. Again, we can flip through a lot of the features that are in here. Some of the notable ones include deduplication, which of course is very, very important as data stores grow. You need to make more efficient use of your actual data that's on space. We can do distributed file spaces as well, which will allow us to hide directories on different servers under the one global namespace and present that to a client, masking the sort of complication of having multiple NFS points or Samba points. Again, Hyper-V integration, so a lot of people are actually using this as a virtualization server, and again, this allows us to optimize storage around that as well. SMB Tree Direct, again, leverages a lot of the functionality that people like Mellanox are providing in their NICs as well, so this provides remote direct memory access into the actual storage solution from the client, providing very, very low latency and high I/O capability from your client to server. Some of the sample configurations, again, if you want just a standalone cost-effective storage NAS or SAN system, we can do that, or likewise if you need some more availability within your solution, we have a unified NAS SAN high availability configuration, which allows us to use two servers connected into one shared storage object and provide that out then across whatever protocol we need to. And then finally on the Windows series side, we've also done work with the Synchro card as well, and this is just one of the sample configurations that we have for that, which allows us to have cache synchronized between two different SAS controllers within our system. Okay, and then again finally, this is one of the sample configurations that we've come up with for the T-Store series Windows Server configuration. And again, now we're supporting SAS 3 as well, of course. Okay, on to the next product. So this is kind of more geared, I guess, towards some of the high end with an awful lot of features and perhaps a bit more of a budget. We've also got integrated solutions based around Nexenta technology. One of the form factors that we've certified inside in the lab is the SBB box, or the server bridge bay, and this allows us to put in two servers internally within a 2U chassis and configure them in a highly available mode. So within just a single 2U box, we have a fully HA storage unified solution which supports iSCSI, Fibre Channel, CIFS, Samba, NFS, and everything else you can think of. It uses ZFS as well to provide an awful lot of its enterprise-based features for things like caching and deduplication. So again, a very thorough storage product. A couple of slides again on all of the specs, and I'm sure you heard a lot of this earlier on from the previous ZFS talk, but things like high availability and snapshotting, deduplication and inline compression and VDI acceleration, all of these fancy features are included as part of the Nexenta solution and make for a very, very high-end storage appliance. Again, we have standalone and highly available configurations, so depending on your budget and uptime requirements, we have options for that. And again, here's a sample configuration for kind of virtualization and VDI. This is our NAS and SAN cluster in a box, which utilizes the storage bridge bay chassis. Okay, and finally on this, so this is just one of the sample configurations we've put together in the lab, and you can see there we're getting over 100K IOPS and almost 2 gigs of streaming throughput off this configuration. So if you were to do a configuration like this using some sort of a tier 1 storage solution provider, I can guarantee it's going to be about 4 times the actual cost of what we have here. This is a very, very cost-effective way of getting very, very high performance. Okay, and finally now onto the data core software. So again, this is another solution that we can put on top of our hardware to provide enterprise-grade storage solutions. It sits on top of Windows Server as an additional sort of appliance on top of that, and again it provides a lot of enterprise-level features and high availability. And actually one of the neat features about this is the auto-tiering capability that we have internally within it. I guess the main thing to speak about here, I guess, is the auto-tiering. So this allows us to put in a set of SSDs, a set of 15K SAS drives, and then some, say, high capacity, lower performance SATA drives. And we can automatically configure the software to auto-tier data between those tiers to suit online snapshotting, all of the kind of features that you'd expect from most enterprise-grade storage solutions. And this one doesn't fall short on the features. Okay, finally we have, of course, high availability and standalone SAN options. And again, here's a couple of sample configurations and specs. I presume the text is just small enough so that you can't read it. But if you're interested in having a look at that, please feel free to get in touch with us. So kind of moving from the enterprise storage more so over onto the HPC side of things, which is my own personal background. I was going to just spend a few minutes talking around Lustre and some HPC solutions that we have. So just to start off with, I mean, this is a quote from one of the editors over at HPC Wire, which kind of really shows how mature Lustre has gotten, and with Intel's backing, how it's looking to become more of an enterprise play as opposed to just a traditional scientific file system that breaks almost every second month when you're actually running it. So just to take a step back again, and what is Lustre? So this is it's a parallel file system. It's an open source project that was initially created maybe 20 years ago, if not more, and designed and developed internally within Sun. They, as a company, of course, were bought out by Oracle, and when Oracle bought them out, they put the source code back out into the community, and a company called WAMCloud then took up a lot of the development of it. They were subsequently bought out by Intel, who are now sort of driving the main development around this technology, but it still remains an open source project. But we've got a huge partner in Intel backing it and ensuring that it's stable and has the correct roadmap in place and the correct designers in place to bring this technology forward. It provides, again, huge amounts of performance and allows us to add more and more storage to a single global namespace and scale out performance in that sort of a means. Very, very resource efficient, and I mean, as it's open source, it's very, very cost effective as well. So it's purpose built for speed and scale. So this was designed as a solution to address HPC needs. So in a HPC cluster, we have 100, 1,000 servers all accessing the same pool of storage for 3 years and so on. With a traditional NFS server or a CIF server, you've just got a single mount point. This becomes a bottleneck when you have potentially 1,000 cores all trying to access the same storage at the same time. What Lustre does is it distributes the storage across multiple servers and allows clients to access that storage in parallel. This allows us to scale up speed, capacity, and efficiency as we add more and more blocks to our storage pool. Lustre is also incredibly efficient, so it can often achieve over 90% of what the raw hardware is actually capable of. Very, very affordable, so we've got low CapEx and OpEx. Again, we can independently scale storage and bandwidth, so depending on what the actual needs are, we can increase the bandwidth by adding more nodes, increase the storage by adding more JBODs or more storage capacity. And of course, being backed by Intel, we've got a very stable and reliable product. So just kind of, what does a Lustre solution look like? So if you might hear it thrown around in circles, but this is kind of what the architecture looks like, and this is what our solutions look like as well. You can see we've got metadata servers up in the top left, and these are the servers that hold a catalog of where all the files are and where their locations are across devices called object servers. The object servers are the ones in green. These are what hold the actual data themselves. And then of course we've got clients, which are compute nodes that are accessing the storage. And we have a management node in there as well, which handles the configuration and deployment of the Lustre system, and then it continues to monitor the server once it's up and running as well, and provide back metrics on utilization and how much free space you have, and tell you which users are hogging all of the space and so forth. So to take you through a sort of a typical I/O pattern, I jumped ahead of myself slightly. Number 3, so these are our clients. And of course there's the fabric, or the network between the clients and the storage itself, and this can be anything from InfiniBand, 10 gig, 1 gig, whatever you need to connect it to. It will work with very much most of the fabrics that we have out there. So what happens when a client actually requests data, it queries the metadata, it says I need my file, it's /home /World Cup results.txt, where will I go and find that? The metadata will then respond to the client and tell it that your files are distributed across servers 1, 2 and 3, and in parallel then the clients will access the files and pull down the data in parallel. So this allows us to achieve very, very high performance and very, very high throughput by distributing the packets of the file across different servers and allowing us to access them all then in a distributed manner. We've actually measured over 2 terabytes a second in performance on Lustre, and it's very, very common to get sort of in the range of 500 to 750 gigs of performance out of it. And just to kind of put that in perspective, you'd be pulling down somewhere in the region of 100 DVDs a second. You can imagine that sort of bandwidth at home for streaming Netflix and whatever else. It'd be very, very, very nice if they could implement something like that over broadband. So it's a great fit, as I said, for sort of more of a scientific background. So anyone that's trying to leverage very, very high performance I/O from research and analysis, I mean, you're probably very well versed in people speaking about how more and more data is being generated, more and more data needs to be analysed, and storage platforms like this really facilitate science and research and investigation at a very, very large scale. So there's various different fields there where this kind of work is applicable, from engineering to bioinformatics and right through to financial analysis as well. Looking at the actual market segment as well, it's actually one of the fastest growing segments within HPC is HPC storage. So it's a good market to be in at the moment, with the vast majority of customers that we're working with all struggling with data deluge. Their users are just generating more and more data. It needs to be stored, it needs to be analysed. It also needs to be retained and reanalyzed again as algorithms are optimized. So you've got this longer retention, more data being generated. It's causing a huge amount of headaches with most HPC customers that we have. In fact, we've just deployed a very large 15 petabyte system in the UK with one of our customers, and they're doing weather forecasting and simulation. But they're already predicting the 15 petabytes already, they're going to need to grow that to 100 petabytes within a year, and it's going to be an exabyte within the next couple of years as well. So that's the sort of trajectory that they're heading on over the next few years. And they still can never get the weather right, which is very impressive, but they're buying lots of kit anyway, so we're happy. Lustre is one of the primary file systems used for HPC, so after NFS, which is a sort of a single node file system, it's the largest parallel file system that's out there. The manager for Lustre is an appliance that we put together on our servers, and this is the one that does all of the monitoring, managing, and gathering of metrics and reporting graphs of who's using what, where, and how. It's extensible as well, so it's got an API that you can actually plug in your own custom metrics into if you so desire. And then, finally, just to wrap it up, so the HPC and Igloo range in general are sort of closely engineered solutions for both the enterprise space and the HPC space. And if you have any interest in either testing any of these or playing with them, feel free to get in touch and we'll arrange remote access or come on site and have a little poke around with them yourself. So thank you very much for your time.